welcome to today's video on Power BI DAX. So here's a quick question for you. Have you ever felt like Power BI is like a cool looking dashboard, but you just wish you could do more with your data? Add those custom calculations or get insights that are a little bit outside the box. Well, that's exactly where DAX comes in. Let's think of Power BI as your data playground. It helps you visualize your data with charts, graphs, and tables. But what if you want to take it up a notch? That's where DAX, which is Data Analysis Expression, steps in. It's like the magic behind the scenes that makes Power BI not just a visual tool but a powerful data crunching machine. So what Power BI DAX is used for? Well, it is used to create custom calculations. If you need to calculate total sales, average profit, or even something more complex, DAX is your go-to tool. You can also build dynamic reports. If you want your reports to change based on user input or the time period, DAX will make it happen. You can also dive deeper with your data. With calculated columns and measures, you can explore data in ways that are more meaningful at your specific needs. So in this video, I'll walk you through how DAX works and show you how to create those custom formulas that can truly unlock the power of your Power BI reports. So let's get started.
Hello and welcome to Simplilearn. In today's session, we are exploring one of the most powerful features in Power BI, DAX, or Data Analysis Expressions. Whether you're a beginner or looking to deepen your Power BI expertise, this video will help you master DAX and unlock advanced analytics for your reports. DAX stands for Data Analysis Expressions. It's a formal language used in Power BI, Excel, and other Microsoft tools. DAX lets you create powerful calculations, data models, enabling you to extract deeper insights from your data. In Power BI, DAX is essential for building calculated columns, measures, and calculated tables, which are the backbone of custom analytics and reporting. The purpose of DAX in Power BI is to analyze data and create custom calculations for better insights and reporting. With DAX, you can go beyond simple aggregations and build metrics that answer complex business questions such as year-to-date sales, growth rates, or profit margins. However, you must be thinking, if you're following up with the previous video where we have learned about interactions and different type of charts, we haven't used any DAX there. However, we still had meaningful insights. Why is learning DAX so important? DAX is essential for advanced data calculations and custom metrics in Power BI. It also enables time-based calculations such as year-to-year, quarter-over-quarter analysis, and helps to create custom measures like profit margin or growth rate. Ultimately, DAX empowers you to transform raw data into meaningful business insights that drive business decisions. Let's look at the types of DAX expressions you will encounter. So within Power BI, first we have predefined functions like aggregate functions, logical functions, date functions, information functions, user functions. Then we have DAX statements. These control the logical flow of calculations, such as if and switch statements, and more. Variable and written, very commonly used statements. Then we have data retrieval functions, which we called as queries. These will help you to pull data from your model. It is often used in Power BI's query editor, like evaluate or define. First, we will explore predefined functions as most of them are similar to Excel. DAX functions come in several categories. First, we have aggregate functions, like you can see sum and average, minimum, maximum, count, standard deviation, variance, and more. Other are date and time functions. You will find them very similar to Excel, like year, month, end of week, weekdays, and more. Another are logical functions, like if, and, or, switch. We'll see multiple conditional logical functions here. Other than these three types of functions, we have information functions, reference functions, parent and child functions that are very specific to DAX. Most utilized DAX functions are common date functions like year, month, quarter, or looking at difference between two dates. Other are time series functions, where we are trying to calculate year on year as variates and written using the year functions, date functions within the statements, figuring out year till date, quarter till date, which is calculating the any numerical like sales, profit, till, year to date, month to date, and quarter to date. These are the time series functions. Other most commonly used are aggregate functions, even when we are not explicitly defining a function. Implicit calculation, as soon as we drag any numerical variable into the canvas, immediately it converts into sum of that particular amount. So if it is sales amount, then it will be sum of sales amount automatically. That is implicit. Yes, we can go ahead and create the explicit, sum of sales, average sales, aggregate functions within Power BI. Other most utilized functions are user functions. User functions like calculate are where DAX gets really powerful. Calculate allows you to change the context of your calculation. For example, summing the sales only for a specific region. This gives us flexibility to answer very specific business questions. And logical functions like if and switch let you build conditional logic into your calculations. If checks a condition and return different results based on whether it's true or false. Switch is like a more advanced if, letting you handle multiple conditions easily. Let's create a calculated column together. We'll label each sale as high or low based on the amount. In previous examples, we have been using one or two predefined functions nested within one another, or simply one function or a statement to calculate one single column or an aggregate value. DAX really shines when you combine functions. For example, to calculate profit margin, we have to go ahead and utilize sum of sales minus sum of cost that we divided by amount again. This uses both sum and simple arithmetic function to give you a critical business metric. For time-based analysis, you might use dates YTD to calculate year-to-date sales or compare this year's sales to last year's. We can use same period last year. We can also use previous year, previous quarter, or previous month. These time intelligence functions are essential for any business that wants to track performance over time. Let's go ahead and see some time series based calculations with DAX in Power BI. As we have already seen few examples of Power BI DAX. Before we move on, here are some best practices for writing DAX. First, keep your formulas simple for better performance. Use measures for calculations, reused across the reports. Instead of adding a calculated column, it is always better to add a measure. Measures are easily reusable across multiple tables within the data model itself. Plus, measures are not the part of a data model. Measures are created when they are utilized inside a report. So measures are always recalculated. So these are always updated if your data is updated. Third, always check how filters and relationship affect your calculations. If you're applying a relationship, it means within a data model. If you're applying filter or the slicer, it is going to affect the DAX calculation results into the report or the visual we are creating. In the next section, we will explore one of the most important concepts in DAX, that is context. Understanding row context and filter context is key to mastering DAX and building dynamic interactive reports. Let's dive in. Let's explore some most used DAX functions in Power BI. This here is Power BI desktop application. In this application here, let's import our data from Excel. We can import it right from here. Or we can click on Excel workbook right here. We are getting a auto sales data set. Let's click on open here. We'll have our navigator window. We can highlight sheet 1. We can look at the data set right now. Let's check on that. We have order ID, order date, delivery date, how many days we took to deliver, which state did we deliver it to, dealership name, regional details, then we have customer details, product details, then we have here packed details. That involves what was the traffic, quantity sold out, leads converted, orders placed, and then the revenue, profit, and cost to company. Let's transform data here. It will take us to Power Query Editor. Within Power Query Editor here, let's check out. This is our order ID. It is at data type 1 to 3. We have order date with the date, number. Let's check the data types for state. Everything is in text properly. Now if we look at the numbers are in the proper date format too. However, if we want, we can change revenue, profit, and cost to company into data type fixed decimal number. We'll add a new step. Let's rename this to, this is our auto sales data. Currently we are ready. We'll close and apply. Our objective here to explore DAX measures here. In the auto sales data here, we have dimensions and measures. Dimensions and measures. Measures are numerical values here. We can see wherever the summation sign is there, these are numerical values. For example, first we have here is cost to company. Cost to company, the summarization here we can see is sum. Similar customer ID, since Power BI understands customer ID is an identification of a customer. It is a unique ID provided to the customer. The summarization here will automatically be count. Similar pattern we can find in other columns too. Let's go ahead and create calculated measures. Simple functions first. For example, we'll create a simple table first. In this table here, we would like to explore that how much quantity we have sold out in each category. If we check on category here and quantity, we see by default sum of quantity here. This sum of quantity is implicit calculation. Implicit calculation here means this calculation is decided by DAX. Now when we go ahead and define the calculation by using modeling, that will be called as explicit calculation, where we are going to use DAX functions and statements. Let's see difference between both. To add the measure here, we can add the measure from new measure here. We can also go ahead and right click on table and click on new measure. We can also click on modeling and add a new measure from here. So let's go to the table, right click on a table, and let's add a new measure from here. When we click on new measure, observe here, a formula bar is opened up where it is directly writing measure equals to as a name. In the data pane, on the right hand bottom corner, we have a measure here. This measure is getting saved in data pane on right hand corner here. We can see the icon is a calculator right there, right here. So let's rename this here as total quantity. Make sure, as a standard practice, we do not leave any spaces. Later on, if we are trying to reuse this aggregate calculation, and if there is a space in the name, we will not be able to reuse it in any other calculation. Now we want to sum. We'll use the predefined function, aggregate function, sum. A simple sum function here. If you want to read more about it, you can expand it from the arrow. I will give you a simple explanation. This is true for any of these functions here. We select the sum from the drop down here. As usual, we can see the parenthesis will open up. It will give us the syntax right here. We have the syntax and the arguments right here, and we have the options to choose from below. Now we want to go ahead and calculate quantity, so we will simply go ahead and type Q in the drop down. We have quantity with the help of tab in our keyboard. We can simply use quantity right there. And since we are in Power BI, remember to close the parenthesis. To commit or save this particular calculation or the measure, we will go ahead and press enter. Once you press enter, on the right hand corner, you'll find total quantity right here. Total quantity sold right here. As you scroll down, you can see the measure is created here. Let's check and utilize this measure in the same table. We can close this from here. Select the table. Let's add the total quantity sold. As we can see, there is absolutely no difference between the explicit and the implicit calculation here. However, now, if we want to move forward and add the average here, we can have the similar average calculated there. But when we have sum of quantity, the implicit measure, if we are collaborating with someone, they will have the freedom to change the aggregate calculation right here. However, when you have explicit calculation, the calculation is fixed. The collaborator can simply calculate the percentages out of that. Nothing more than that. So aggregation cannot be changed. So if we want average quantity to be sold out to individual customer, we can go ahead and create the explicit calculation for that too. As we can see, what we have here is cost to company and the quantity plus the profit we have made out of that and the revenue. So let's calculate. Let's create a simple table where we want to analyze how many average days we take to deliver to certain estate. So here we have list of estate, and now we want to calculate average days we take to deliver. First, let's look at the implicit calculation, which is by default sum. So we'll go ahead and create a new calculation here. We are at the Home tab. In the Home tab, on the right hand side, we have a new measure. So let's click on new measure. We are going to call this average days to deliver. To avoid the spaces, you can also add underscore sign. In average days to deliver, we start with average function. Now we have days to deliver, and we close the parenthesis. Once you press enter, we can find average days to deliver is here. Let's check here. In this report, here, next we would like to calculate that if we are taking more than 5 days, meaning we are taking longer duration to deliver. So that is not a expected KPI. The average days to deliver, if that is equals to 5 or less than 5, that will be considered a good performance. For that, we add a new measure again. So currently, as you can see, we are in the measure tools. In measure tools also, we have new measure here. Measure tools is opened up because we are currently selecting a measure. Let's click on new measure and apply a logical condition. The logical condition is going to tell us about delivery performance. We'll simply go ahead and type I. In the drop down we have if. In the if here, see the syntax, it is pretty similar to Excel. Logical test is here. In the logical test, we are saying that read average days to deliver, the measure that we have here, if it is greater than or equals to 5.5. If condition matches, then the performance needs to improve. If result is false, it means it is just opposite, meaning we are doing good. So the performance is good. So we have one condition and two output. Now we can see our measure is saved here. Let's check on the measure. Now we can see whether each state, what is the average days, and whether it is good or it needs improvement. Let's keep a slicer here for region. This region size slicer will give us more insights here. So within the central region, we need improvement. In east here, we are doing good in few states. We need improvement, and we need improvement in most of the cases here. Let's look at few more common functions like date functions. Currently, if you want to go ahead and create a table, we want to see year-wise sales we have done. We have delivery date and order date. Let's use the order date here. The moment we check on the order date, the entire hierarchy will be added here. We can simply check and decide to keep whatever we need right there. However, every time extracting and checking from here is not always desirable if we want to go ahead and utilize the year and month within another calculation. So maybe we want to simply go ahead and look for the Q1 sales. In those cases, we will not be able to extract Q1 right from here. So let's go ahead and look into most used date functions here. We add a new measure again. In this new measure here, let's get the year extracted. We can simply use a year function. In the year function here, we have to write a date. So date it will find here in order date. As you can see right now, when we are using year function, we do not have the option to select the measures here. The reason is there are few functions that can be used within calculating measures. However, few functions like year, month, quarter, and more, these can be used only when we are adding a calculated column. So here you will find some limitations related to context. To understand more functions, we have to look into calculated columns and calculated tables. So first we are going to add a calculated table for calendar, and then we will move forward and add calculated columns in that. We'll also understand why calendar is important to be added and how we can use multiple date functions and logical functions to create a proper calendar table. By learning that, we will cover the concept of row context and filter context too. Now, we are going to explore one of the most fundamental concepts in DAX, that is context. Understanding context is absolutely essential for writing effective DAX formulas. There are two main types of context: row context and filter context. Let's break these down. We'll see it with an example. For the example, first we'll add a calculated column. To add a calculated table, we will go to the table view. And here, let's add a calendar table. And within the table, you'll understand about row context and filter context. To add a new calculated table, currently we are at table view. In table view, we'll have table tools open here. In the table tools, we can see the types of calculations we can add. Currently, we are going to work with new table here. Once we click on new table, observe here on the right hand side, we have a calculated table icon, and here also we have a table. What we are looking for here is to create a calendar. A calendar in Power BI is a column which contains continuous date since the start to the end. This calendar table is helpful and required if you want to do any kind of time series calculations. The easy way to create your calendar table is use calendar auto. It's an automatic calendar. It will automatically figures out from the model wherever is the starting and the end date is. Currently we have one Excel sheet, so we are good with it. We can simply open and close. We don't require to add anything inside the syntax argument, as fiscal year month we can see is optional because it is in the square brackets. It can automatically pick up from the data model or imported data that we have here. As we can see, we have this calendar table here. The column is added, that is date column. This date column, let's select the date column here. Column tools will open up a new tab. This is not date and time. We are only looking for date here. There is no time component within it. And the format is a small date format, and we are good with that. Now let's talk about the context. Row context. Row context is essentially the DAX's awareness of the current row when evaluating a formula. It's automatically created when we work with calculated columns. For example, currently we have date. We want to go ahead and extract year, month, quarter out of this date column. So we will go ahead and add a new column here. And in this new column, see, a new column is added. So we want to go ahead and extract year. To extract the year, the function is year. In the year where our date is, in the calendar table date, so we can find it calendar table and date. With Power BI, we have to give the entire address, entire location of where the column is. So we are telling table name and then the column name here. This formula is evaluated for each row individually. So if we are asking it to extract month, it will go ahead and extract month from individual column, individual row here. So we can add one more column here, and we can ask to get the month here. So the month calendar table here. You will have the month number. Now if we need quarter, we can add a new column again and get the quarter here. We get the date again. From the date, extract the quarter. And both the cases, it is going to be numbers. As you can see, it is January, quarter is 1. So this year is always seen as calendar quarter. If you want to see the month name, We'll again write one more calculated column again in the row context because it will evaluate for individual row, where we want to go ahead and look for a month name. For the month name here, we will go ahead and use the custom formatting, that is the format option. It is parallel to text function in Excel. In format function, we will give the value and format it. To extract the month name, we will use the function format. Format function helps us to custom the format of any given numerical value. And this value converts any value to a specified number format. So for example, we are getting the calendar date here, comma. The format we are looking for is month. So we can ask it to extract month. We will write M 4 times there and the month will be extracted. Next is local name. So we are not looking for that right now. And we close the bracket. This is not as per local or time zone. We simply want the month out here. So we don't need it right now. And this is format. This is month name. Every column that we have added, it is based on row context. It is calculated for individual row. Notice how it calculates for individual transaction. This is row context in action. Next is filter context. To understand the filter context here, let's go back to the report view. In the report view, let's calculate total profit. So the filter context, on the other hand, is about which subset of data is being considered for a calculation. It's created by filters applied to visuals, slicers applied on your report, relationship between the tables, filter arguments in DAX functions. Filter context is crucial for measures which don't have an inherent row context like calculated columns do. Let's see filter context in action with a measure. So let's add a measure here. Measures work on filter context. Let's calculate total profit. To calculate the total profit here, we use sum and we ask it to get the profit from the data. When you place this measure in a visual, for example, showing profits by region, when we place this measure in a visual showing profits by region, the filter context for each region determines which rows of the profit columns are summed. If we click on West region, in the slicer, the filter context changes and our measure recalculates to show only average days to deliver in West, sum of quantity or total quantity only in the region West. Similarly here also, we can see it will show only region West. This is the default filter context. This filter context can be modified within the DAX measures by using calculate functions. The calculate function is one of the most powerful functions in DAX because it allows you to modify the filter context within the formula. This is how the calculate function syntax looks like. As we can see here, calculate function evaluates an expression in a context modified by filters. If you look at the syntax here, it says that first you give the expression and then the filters are applied. So for example, we want to calculate the profit only for certain category of product. So let's see here, certain category of product, we have hatchback, MPV, sedan, and SUV. So let's calculate the profit only for SUV. To do that, we'll add a quick measure here. I'm naming this as SUV profit. And here we use calculate. And calculate, we are simply asking them to calculate the total profit. So here I'm using total profit. You can also go ahead and write sum of profit. In both the cases, it will go back and re-execute that particular DAX. Now here, we will go ahead and give a filter. A simple filter will be that go to auto sales category, which should be equals to SUV. This is the SUV profit here. See the difference? If we add the cards here, this is our total profit from all the regions and categories. This here is SUV profit, only profit that we have gained from SUV. This overrides any existing filter context within the specified filter. So if I go ahead and select central, for example, here, you can see SUV profit gets impacted by the outside filter right here. Context transition is what happens when row context gets transformed into filter context. This occurs when you use an aggregation function inside a calculated column or when you use a calculate formula here. For example, if you want to calculate what percentage of SUV profit contributes to the total profit. In this case, context transition will happen. If we click on new measure, and we will see it here. So we want to find profit contribution. We want to find profit contribution percentage of SUV. So here, we'll get our SUV profit that we need to divide it by. So we can use divide function here. SUV profit is numerator. And denominator here, now we want total profit. So now we will write calculate here. Reason, we don't want this denominator to change or get filtered out because of slicers or simple selection of Central, East and North here, because this total profit changes when we select anything from out here. We want it fixed. So SUV profit is going to be fixed. It is from SUV. In the calculate here, we want to fix the total profit value. So we type calculate and we need total profit here. And here we use all function. This all function returns all the rows in a table or all the values in a column, ignoring any outside or even inside filters. Inside all function, we'll ask it to keep the entire auto sales data intact and not to get this particular total profit impacted by any outside or inside filter. Here, the all function removes all the filters from the sales table, giving us total profit across all the product. Let's see. Let's implement this to see which product contribute most to our overall profit. I'm going to add a card here, multi-row card, and let's see the profit percentage here. Let's convert into percentage too. So it is in general format right now. Now it's percentage. See. So the SUV contribution here is 25%. If I convert this into a simple table right now, maybe we want to see in front of category, you'll find that it is only giving us the SUV percentage here. It doesn't understand this at all, meaning this is a fixed percentage answer that we get. However, if we go ahead and add fuel type and we don't see the category here. Now we'll have a correct percentage right there. So while calculating this here, it is able to hold on to the total profit calculation right there. So this is your profit contribution as per the given type. And see here, this is not 100%, this is 24%. That is only for the USV. That is only for the SUV. The same can be applied to calculate profit contribution for each product. I'll copy this here and let's create a new measure. Now we want profit contribution for all product here. Or let's say each product here. So now here we do not have SUV profit here. Instead of that, we will ask it to get the profit. And now here we are asking it to fix the profit right there. This total profit always gets filtered out. However, the second total profit, which is used within the calculate function and with the all function, this is going to be fixed in the output. When we calculate it like this, and now if we go ahead and create another visualization where we want to see each category contribution and profit. Let's convert this into percentage. You'll find the percentages right here, which amounts to 100%. If we go ahead and simply put total profit here and calculate the percentage from here by utilizing this, we still get the same answer. However, when the outside filter is applied, see the difference. If I'm filtering right now with the central, which is the interaction right now, if we are selecting central here, now we know that in the central, the all over contribution of these is 7.32% within central out of the entire profit. However, here we see 16% for hatchback and likewise. Reason? This particular profit contribution is coming always from the fixed total profit of 601.78, entire total profit. So these look same, but this profit contribution cannot be impacted from the outside or inside filters. Now that we understand the context, let's explore some advanced DAX functions that leverage these concepts. In this session, we will analyze auto sales dataset by using Power BI desktop. Continuing from the previous topic, we have an understanding of context in Power BI DAX. Moving forward from here, we will guide you through every step from connecting to the data, exploring the data model, defining key metrics, using advanced DAX formulas like time intelligence, forecasting, dynamic titles, etc., to building rich reports and dashboards. By the end, you will have a solid hands-on understanding of how to turn raw auto sales data into actionable insight with professional visualizations. Throughout the tutorial, feel free to pause and try each step yourself. We will also provide explanations for the main concepts and formulas. Let's get started. Open your Power BI desktop. We can go to Get Data and click on Excel workbook here or here. Browse and find auto sales data. Click Open. In the navigator preview, select the table, the sheet 1, and click on Load. Power BI will import the data and display it in Fields pane on the right. This creates a new table in your data model. At this point, check that order date and delivery date columns are recognized as date or time types. Under the column tools, this is the date. And numeric columns like cost to company, profit, quantity, revenue are numeric. Let's go to Power Query to adjust the types. To go to Power Query, go to Home tab and click on Transform Data here. This redirects us to Power Query Editor. This dataset now serves as our fact table of auto sales record. We can check the data types right here. From decimal number, fixed decimal, whole numbers, to date, time, and the binary too. These numerical value can be converted into fixed decimal number, that is currency. We always add a new step. From here, we will go ahead and first rename from sheet 1. So let's rename this as sales. Let's close and apply. It will close the Power Query and load the data into Power BI. The data set now serves as our fact table of auto sales records. In a more complex model, we might split this into fact and dimension tables. For example, separate tables for date, product, and dealers, and separate table for numerical variables like order date, orders, profit, quantity, revenue, traffic. But for now, we have one table containing orders, customer information, sales figures, and so on. After loading, notice that our data model currently has a single table. In a robust BI solution, we often create separate dimension tables. For example, we could extract a unique date table from order date column, or separate tables for region, dealership, product, and customer. Creating a proper date dimension and marking it as a date table is important for time intelligence calculations. In fact, Power BI and the DAX engine requires you to mark one table as a date table to get correct results for time intelligence functions. For example, you could duplicate the order date field into a new table of unique dates, and under Table Tools menu, use Mark as Date Table. We'll assume a proper date table is in the place. This date table we are referring to is the calendar that we have created in the last few steps. So let's go ahead and see another way to create a calendar. So we'll go to the table view. In table view, we click on the new table. This is our date table, or we can also call this as calendar table. And we ask for automatic calendar again. We will select this column and convert this into date. Now this is a separate table altogether. We'll go back to data model and we make sure that this data table is connected to order date in sales data. So we are making sure that this table is connected to order date here with the help of common column. Once the relationship is created, observe that the cardinality is 1 to many, meaning date here and date table are unique. However, order date here is repeated, since multiple customers can place multiple orders on the same date. However, this creates a unique list of continuous dates. Now let's go ahead and mark this as a date table. We'll go ahead and we mark this as a date table. We'll click on the 3 dots or epsilon right here. And from here itself, we can mark as date table. We'll switch this on. We choose the column date. It is validated here. Let's read everyone. The built-in date table that are already associated with this table, that is the order date, it will be removed. Meaning, now we cannot use order date within visualization. We have to use this date table only, since it is going to be continuous date. Look at the icon will change like an ID rather than having a calendar like this. Meaning now this is a continuous date. As before, we can go ahead and keep on adding year, month, quarter here. That is going to be our row context calculation right there. Let's see a new way to create a calendar table. As usual, we'll go ahead and click on new table. This time, we are going to name it dates. Remember that Power BI DAX is a functional language. It has its own way to write. We can move to the next line here with Shift and Enter. Now, when we say it's a functional language, meaning we have to give indents, we have to open parenthesis, close parenthesis at its places. It has a structure and format to type. Although it is used as a guideline, and since we are beginners, we might not have a full knowledge of how to write it. In that case, there are multiple websites that can help us to reformat the Power BI DAX. For now, what we are attempting to do is we are trying to add a new table. In that new table, we want to first need a first column where we have calendar. Now in that, we have added the entire calendar date, meaning a continuous date without any gaps. Then we want to add year column, month column, and likewise. To do that, we will start with add columns. Now add columns here returns an entire table with multiple columns at once. So we don't have to add individual new column every time we want to add something new. So now we'll go ahead and type the entire code to get the full calendar table. This is add columns. Add columns is asking here what will be your table. The table here will be our calendar auto. That is automatic calendar here. I will take this to the next line too. Indent is automatically there. Now within the syntax, it is asking us the name there. If you read the syntax, it is asking name of the column there. So we will say the column name is year. Now the expression, meaning the formula, should be year, and it should go ahead and get the date. Now how do we define that date there? So it is going to be dates. Here is the date column right there. Close the parenthesis, comma. We need month. So we're getting month number. The function is month here. And here we have date. Likewise, with Shift and Enter, we will move towards the next line, and we can keep working with new columns right here. Now we don't have to add columns every time and write them separately. It saves us so much time. Editing is easier. We don't have to work with individual columns anymore. Adding, deleting, and managing your columns becomes easier. These are the exact same functions we have already applied before. Now, as and when required, we can go ahead and add more columns in here. Currently, I am adding some basic columns here. Let's see an example, then we'll keep on adding the columns. And see, here we are. In a similar manner, we can also go ahead and add the quarter name for year. So here, let's see, we have 2024 quarter 3. So we are utilizing our format function again. We are extracting year, then we are concatenating it with quarter here. So likewise, we can move forward and add more columns in here. Now once we have our date, that is our calendar table, and the sales data here, first we will make sure that our date column here is marked as date table, so that it is recognized as a date table here. We'll also make sure that in the data model here, this date is connected with order date to determine the relationship properly. And now order date will not be used for visualization purposes. Now we will use the date always from the dates table. Now let's move forward and understand DAX. Now we create key performance indicators as measures. We will go to report view. We will go to modeling tab, and click on New Measure. In this new measure here, let's define few KPIs here. First, we have revenue. So the first measure here will be total sales. We'll sum the revenue. This sums the revenue field across all records. Let's add one new measure, units sold. This sums up total number of cars sold. Make sure your home table is sales data, meaning the formulas are getting saved within the sales data only. Our data has a profit column. So we right click and hit our new measure. To illustrate, we can write gross profit here. So let's calculate gross profit. We do have cost of company. So let's figure out the sum of profit deducted by sum of cost to company. This follows the example of a profit measure as an aggregate difference. We'll add a new measure in sales data. Since we have a difference, gross profit, let's find out profit margin percentage here. We define the profit margin percentage by dividing the entire profit by revenue. This will compute the profit as a percentage of revenue, avoiding divide by zero errors with the help of divide function. In divide function, numerator is sum of revenue. Denominator will be revenue. The numerator is going to be the profit. Denominator is going to be revenue. Sum of revenue. Alternate result. Even if we leave it alone, it will be 0. Divide function helps us to avoid divide by 0 errors. Now we can move forward and create visuals here. We can go ahead and figure out, let's see, total sales by individual region. We can choose to create simple bar graphs too. So first, let's figure out a simple table for region-wise total sales. We can convert this into a simple column chart. You can keep this column chart. This is region by total sales. You can go to the format. We can switch on the data labels right here. Currently data labels are in billions. We can choose them to keep it at the outside end. In the values, let's fix the units at million. We'll select the theme later. For now, we'll keep our chart right there. Next, let's see product by sales. We'll add the table again. So this is product and total sales. Now we have got multiple product here. the best here is the bar chart. Let's keep it right there. Again, we can switch on the data labels right here. We will fix the data label values at millions. We can make it bold to make the color appear here. Let's decide the decimal values to be 0. Let's give a background color right now so that it is the charts are easily visible. Right. Now let's see dealer wise. This is our dealership name and total sales. Here we can create a bar chart again. Let's total sales by dealership here. As usual, we'll go ahead and switch on the labels. And we fix our labels with display units millions. Now, let's move on and see some time series calculations. To use the time intelligence functions, we have to make sure that our date is marked as table. Let's see a few examples. We'll make sure we are clicking on new measure again. A new measure here. First, let's figure out what is the sales YTD, that is year to date. For year to date, month to date, quarter to date sales, use DAX time intelligence functions like YTD, MTD, and QTD. Time intelligence in Power BI uses special DAX functions to compare and accumulate over dates. These let us easily compute year to date, month to date, quarter to date, year over year changes. For example, YTD here total YTD here begins on first day of the year, ends with the last date column after applying specified filters. Can sum the revenue from the start of the year to the current context. Dates we are looking for is from the dates table right here. Before these will work correctly, ensure your model has a designated date table as we have created just now. Next, for month to date and quarter to date, we will follow the similar time intelligence functions like these. So we're creating a new measure here. Let's see the sales month till date. We have total, MTD, and sum the revenue. Same will be followed with sales QTD. Let's also compare last year's sales versus current year sales. For previous period comparisons, we can use functions like same period last year, date add functions, parallel period, or previous year, current year, or previous quarter, previous month here. So let's use the very famous function, same period last year. This is last year versus current year sales. We use the calculate function. In the calculate function, we are going to ask that go ahead and give us total sales, calculate total sales based on following filter. The filter we will give with same period last year. It is going to go ahead to the sales data. It connects with the calendar table and it will return the set of dates in the current selection from the previous year. So the current year is 2025. It will go ahead and select the 2024. If the current year is 24, it will go back and filter out your table by 23. If you're in current quarter, let's say you're currently at quarter 1, then quarter 1 of 2025, then it will go back and select the quarter 4 of 2024. It is not specified with whether it is an year, month or quarter as we have seen so far. Same period last year, it will simply go ahead and select the entire rows based on that particular period. It can be year, quarter, month or weeks. Here, we will simply ask it to filter down the dates column right there. This is last year versus sales. So let's see in the next page here. I'm adding a multi-row card for now. And this card here, let's look at. Let's add a table here. In this table here, first let's go ahead and get our year and month name here. So we have 2 year and month here. Observe that month is not in the sequence as we would think. Month is in the alphabetical sequence, and that's not what we expect, right? So we go back to table view and we'll select month name. Highlight month name here and ask it to sort by month number. When you go back, you will see now that it is properly designated. The sorting is fine. Now let's add the calculations we have done so far. This is sales year till date. This is quarter till date. This is month till date. As you can see, this is January, February, December. So the numbers you will find are absolutely different. This is yearly, quarterly and monthly. Now let's compare last year sales with current year sales. For that, we add one more table. Here, we are going to add year first. And let's add last year versus current year. What we see here is just 2025 sales. Let's add month name. Let's add quarter for now. Now let's see here, this is last year sales right here. Whatever sales we are looking at is from the last year. I would like you to compare this year. This is 2025 quarter 1. And look here, this is 2024 quarter 1. What we are actually looking at right now is 24 number right here. What we here have is last year sales. Let's bring this year sales here and immediately you'll see the difference. This is this year sales and this is the last year sales. Now we can see the comparison right here. To compare last year with the current year sales, we need to create more DAX measures. This is where the KPI measures will come in force. So let's compare profit for individual year. So right now we have last year's sales with us and this is current year sales. If you want to see how far we have went from year on year or period by period, how far we have come around here. In that case, we have to go ahead and see the comparison, whether last year is greater than current year or not. First, we'll create we will create new measures here. When we click on the quick measure, a pane will open up. Here we have certain inbuilt calculations here. We can aggregate as per category. We do have filtered calculation, and here we have time intelligence function right there. We can talk about year to date, quarter to date, month to date, as we have written here. We also have an option for year over year change, quarter over quarter change, and month over month change here. Since we have seen the last year sales, let's see how do we track quarter over quarter change. In the base value here, we are looking for profit currently. So let's bring profit here. In date, we can click on add data. This is the date right here. Number of period is 1, we are fine, and we click on add. Wait for a few seconds here, and the function is written for us. So currently, Power BI has used a statement. First is variable, that is the name of variable is previous quarter, and calculate function with date add function is giving us the total profit for the last quarter, that is -1, that is last quarter. And now it's dividing it by the total profit here. Let's go ahead and bring this percentage profit. It is formatted in percentage automatically. Let's bring this percentage profit right here in the table. And here we are. Now we can see quarter on quarter growth right here. These are few examples of time series analysis. Now let's go ahead and create some visuals. We apply the functions that we have calculated, the measures, into some visualizations. Then we'll learn about analytics and Power BI. Let's outline the report pages we will build. First, we are going to create a dashboard overview. Here, we can use card visuals for KPI visuals to highlight high-level numbers. For example, we can create a card here for total sales, another card here for total units, so this is the card visual here for total sales. Following up the same here. Giving the gross profit here. We can add it for total quantity, that is units sold. We can also use Power BI's KPI visual to show actual versus target. Here is our KPI visual. In this KPI visual here, let's look at total sales here. As per month, as compared to last year's sales. Once it is filtered down to last year or month, you will be able to see the axis. We are fixing the display on its callout values. We you can use Format Painter. With colors here, we can see whether we are above the goal target or not. The target currently that we have here is our last year sales. Next, from this page here, we have our total sales by region, total sales by dealership, total sales by product here. We can keep all of that at dashboard overview. The theme can be set and designed later. Now within here, we will see more here, category with sales. We'll have one more chart here for region, for state and sales. State and sales can be easily changed into a map. We'll keep a small map here. In the bubble map here, we have the bubble sizes with total sales here. Let's go to the format your visual. In the bubble size here, currently it is automatic. You can ask it to use the data range right there. And we can now see it changing. You can also utilize the legend here or the color here as per the region here. That's great. Now we cannot have, now we don't need the title at all. So we can go to general here, switch off the title. We have got the legend right here. We are fine with the legend right now. We can keep it at the center. This is category by total sales. We can convert this into a donut chart. In the donut chart here, we will switch off the legends right now and we go to detailed labels. In detailed labels, we can ask you to only keep the category and percent of total right here. It is not properly visible here. We can go ahead and change the font style and font size to make it more visible. To quickly design it, we can go to view here and apply a certain thing for a quick design. From here, you are free to choose any design you need. This is all about your theme. Most of the time, this theme is provided by your organization. Currently, I'm sticking with a very simple theme right there. This is our dashboard overview. Next, let's create a sales trend page here. So we'll go ahead and see the sales trend page here. In this sales trend page, let's color the background. First, we'll create our line chart because we're looking for a trend here. From here, we'll add the year and month right here with year and month and total sales. Now we go to the analytics pane here in the visualizations pane. Here is the line chart. You can switch on the markers and the visuals. Since we are in the line chart, we will not be switching on the data labels here. We are more interested in looking at the patterns and any seasonal changes here. This is the overall total sales. Within here, we can also go ahead and add gross. We can go ahead and add here the legend. In the legend here, if we add category, into the legend, we will be able to see the trend over all the three categories right here. When we go here into the lines, we select individual hatchback, for example. If you want to go ahead and give different colors to it just for the recognition, we can go ahead and actually do that from here. You can see the line right there. For hatchback, currently it is near to black. Likewise, we can go ahead and check for individual series, and if you're looking forward, we can go ahead and change the color and line here. Color of the line here. This is for individual category right here. So let's create the trend for all the three categories here. We'll add a slicer for category. Let's convert the slicer here with vertical list and single select. We are going to keep it on top of the line chart. When we do this, when we keep it on top of the line chart, we will make sure we go to format and ask it to bring to front always. So when you click here, it will still stick here. When you click, you can see individual lines right there. After this trend here, let's look for the trend of year and quarter with gross profit. For now, let's create a stacked area chart. We can see over the quarter, the sales has been going down. Here, let's add units sold into the mix. Now we can see units sold has been almost similar. Very little difference here. In the small multiples here, if we add year, we can see we do not have data for all the 4 years. We have data only for 2024. So it doesn't work. This is the quarterly trend of profit and profit margin. We can see it is going below over the time, even though total sales is currently going up. So currently we have total sales, units sold, and the profit margin. This is quarter on quarter here. And remember that this is only for the hatchback. For MPV it is going to be different, the sedan it is different, SUV is different. If you want select all option here, you have to switch on the select all here. However, when you say single select, all option will not be available. If you want all option, then we have to make sure that this is just checklist, not an individual selection. In the quarterly one here, we can go ahead and switch on the data labels too. See here, data labels doesn't make much sense, it looks crowded. So if anyone wants to look at the data set, they can simply hover the cursor over there and they can easily see all the three numbers right here in the tooltip. Let's add a separate chart for the comparison of profit margin over the fuel type. Let's bring quarter here into the legend. Now we can see in every quarter how within petrol it was lowest in the quarter one. It went up This is diesel, and here. Let's switch the quarter and the fuel type. Easy to know now, right now. This is quarter 1, quarter 2, quarter 3, and quarter 4. We can see here right now. This is CNG, diesel, hybrid, and petrol. Now this quarter is aggregate quarter for individual year. We do have only 1 year. So let me show you by adding the slicer here. If I add a slicer here for year, let me convert this into a vertical list. We see you have only 2 years, but 2025 we have absolutely no data. For 2024 here we have the data. So we are good with 2024 individual quarter right here. The numbers doesn't change. Remember that. Go to format and make sure you bring it to the front. So this here is our profit margin for petrol, diesel, hybrid, and CNG auto vehicles right here. You can easily see right now, if you look at CNG here, alright, so CNG has been for quarter 1 and quarter 2, it has been the lowest. In third quarter, it was giving the highest profit margin, and fourth quarter it goes below. Similarly, we can track diesel, hybrid, and petrol. Petrol definitely shows us the increasing profit margin. Next year, we'll add with performance versus targets. And performance versus target, we'll go ahead and create few more DAX measures. These DAX measures are going to help us to determine how much traffic we had, how much customer traffic we had. Out of this, how many leads we were able to extract. And then we are going to compare this with the achieved revenue, sales, and profit. That is going to be performance versus targets.
That's a wrap on this video. If you have any doubts or questions, ask them in the comment section below. Our team of experts will reply you as soon as possible. Thank you and keep learning with Simplilearn.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.